Oh, Gary, you need to make your mind up. You can't have stuff both ways. You're up here in the parking lot, 72 or 73 feet above the water. The water is level. And you say you see level. You see these parallel lines. Well, this isn't parallel. This is. This isn't level. This is. There's a difference here of 0.2 degrees. And then you say, at 20 seconds in this video, he shows two parallel lines, but oh look, perspective makes them converge at the other end. Tommy can't apply his geometry to perspective, so he gets confused. And down here, train tracks are another example of parallel lines, and they never converge. Except in your eyesight, they do converge. And as you see here, it's LOL, LOL, LOL. He likes this LOL very much. LOL. He's laughing a lot. Well, let's just see about this one. I don't have any train tracks, but this is the road I'm going to show you later in your own video. You see here at Island Road. These lines, they meet at one vantage point. I don't deny that. That's we agreed on that one. If we zoom in, they still meet down here. But my problem is when you go there and you see this road for yourself. I'm just going to go back on Google Maps. And where? There. This is the same place. The lines seem to meet at the end here. But if I go down that road, it's still parallel. They doesn't meet. They don't meet. This is parallel lines. You can go as far as you like. Parallel lines don't meet. Just as train tracks, they don't meet. They look they are parallel. They seem to meet, but they don't. This is how perspective and parallel lines work. So if we go to this picture, that's a beautiful sunset. I took the picture just the other day. This is just west of Oslo Airport Gardermoen in Norway. And these lines follow the lines in the clouds and the glare. This is the lines of perspective going into one vanishing point here. This is the sun. And the sun is lighting the underside of these clouds. So this needs to be the same line going into the sun. And if we go sideways, this is how it needs to look. Because I see the lines of perspective going here, and I see the sun shining here. So this sun needs to be down here to follow the rules of perspective. If the sun moves here in this altitude, there's no way these lines are going to cross, because these lines are parallel and both of them is level. So the sun needs to be down here. Agree? Didn't think so. So if we go here to my SketchUp model, the sun on the flat Earth needs to move around Tropic of Capricorn once every 24 hours. That's 2,000 miles an hour. And if you put that sun under the clouds, to be able to follow the rules of perspective, then you and your neighbor doesn't see the sun at the same place, and it's traveling 2,000 miles an hour right over. That's fast. So how are you going to explain that? And just to round this off, this is the road from Google Earth. And you show me this. You're lifting the phone from the ground, and say 5 or 6 feet up in the air. And you think that in any way can be the same as this. How dare you compare them? This is how you do it. This is how you do observations. See this small sailboat? See the buildings on the other side? See the curve of the water? Things disappear. Here. This is how you do observations. You're not lifting your phone 5 feet off the ground on a road. You have no idea if it's 100% flat or not. See the horizon getting closer. There, the boat is over the horizon. Just because the level, the altitude change. So Gary, until next time, make your mind up, please.